Gosh dang, I screw this up every time. Starts to drive me nuts after a while. You got to listen to all that clicky click. All right, now, units of energy. A lot of time in the United States, we use calories. As a matter of fact, it's capital C calories. When we look at the nutrition information on a package of food, we see how many calories are serving something has. So the energy content of the food is given in joules. All right. Everyone else uses joules, and that's what we use in physics too, is a joule, and that's what your light bulbs use. Well, it's in 60 watts, but that means it's burning off 60 joules per second. Okay, my my chair who devised this course got these pictures. I think this is on their back porch when he was on sabbatical in Australia many years ago. And he just thought it was interesting that when he bought his Raisin Brands Sultana brand, that it had 1,420 kilojoules when you added milk instead of when it had number. It says energy instead of the number of calories, right? And so a lot of people may not understand what the heck 1,420 kilojoules is. How many calories is that? Type thing. Well, low joule cola. This is from Germany, and I don't know where these are, but low calories, low joules, energy required to play basketball. Okay, so a 200-pound person playing 12 minutes of full court basketball will burn around 200 calories. In contrast, talking on the phone for 12 minutes will burn about 19 calories. How many joules has the basketball player used in the 12 minutes? You need to know something here. So let's just do the calculations. All right. Since I've got my thing ready to go, let's just do this. Here's the thing. 1 calorie, and we'll use big C, 1 calorie. And now, those of you that are my former 210, 220 students that have had a lot of chemistry, we're talking the small c. We're talking the big C calorie, the kilocalorie, really. So we're making so 1 calorie is equal to 4,180 joules. It might be 4,186. I'll have to check. I like to go with 4,186 in my physics class, but I think years ago I based your homework on 4,180 joules. So 1 calorie equals 4,180 joules. So if I burn off 200 calories, I just multiply that by 200. I get 200 times 4,180 joules. And that comes out to be 200 times 4,180. 8.36. Oh, sorry. 8.36 times 10 to the fifth calories. And I think on Blackboard you use a small e for exponents. So that would actually look like this: 8.36 times 10 to the fifth joules. That's which is the same thing as 836, and add 3 more zeros. So that would actually be 836 kilojoules. Because to get a kilojoule, I divide by 1,000. Because 1 kilojoule is equal to 1,000 joules. Okay? So these are the notes. Oh, there it is. Oh, so he did 4180. That's where I got the 4180. Right here. Okay, cool. Let's see what else we got here. All right, so there's calories, 160. Now, you got to be careful. How does this compare? Now then, so to burn play basketball full court for 12 minutes, 200 calories. How does this compare to a single serving of potato chips? Okay, notice 160 calories. Now, you also have to be very careful with these guys because they'll say, oh yeah, a serving is 8 chips. How many of you, when you've had 1 Pringle, can just eat 8? How about a half a can? Just because it's got, and you're gonna do a food article. I've got one of my assignments is you're going to do food articles from, and it's a lot of fun, from Scientific American. You'll look at why potato chips really go into our pleasure centers as human beings. It's an evolution. You're fighting 200,000 years of evolution, you know, when you eat things like high fat, creamy, gooey, you know, macaroni and cheese, you know, those types of sugars, those types of things. That is human crack, legal crack. Right. Anyway, so food energy. All right, now notice energy density. This is kind of fun. The energy that's in food, the material. All right, so fat. The energy density is pretty darn high, right? It's a lot of energy. There's a lot of energy per. Now, what is this? So a lot calories per grams. A lot of energy per gram or per unit of mass in these things. Ethanol, alcohol. A lot of notice fat. See, if we could figure out a way to turn our fat into an alternative fuel. I mean, we would be cooking with gas, you know. Hey, lose 30 pounds and fill up your car with gas type thing. Proteins, they break down the carbs, not as much. Gasoline, notice human fat still has interesting. Food has a greater energy density than TNT. TNT does not have that much energy per gram. Not much at all. Why is it so volatile? Because it's volatile. Because that's what an explosion is. It releases that energy instantly. This energy takes forever to release. Just ask me. As you get older and you get more set in your ways and you get more sedentary and you sit on your ass longer and longer and longer, you gain, you know, here's a statistic that you can't, that's just going to happen to 90% of us. You're going to gain like 1 pound a year for every year of your life, for the most part. You taper off when you reach like your mid 70s, and you start to lose. But from like 55 to 70, you gain almost 2 pounds a year just by living your normal life, because you're slowing way down, your metabolism's changing, and you know you're just fighting evolution. So here's the Snickers the mad science when you mix it with potassium percolate. All right, is an oxidizer that makes the fat disappear really, really fast. Here, I'll show you some gummy bear films. So out here,